Let's go ahead and take a look at solving polynomial inequalities by graphing. We're going to be working with the function x minus 2, the quantity squared, times x plus 1. And we want to know when this function is going to be less than 0. Ultimately, we want to go ahead and graph this function, but let's start by taking a look at our zeros. All right, we have a couple different ways we can do that. Remember that when you're looking at your factors, it's always going to read x minus your 0. So we can either pull the number from that set of parentheses, or we can go ahead and take the individual set of parentheses, set it equal to 0, and solve it for our x value. So for example, on this first one, we can do x minus 2, set it equal to 0, and then solve it for x. It's going to give us an x value of 2. And let's go ahead and do the same thing with the x plus 1. If we set that equal to 0 and solve it for x, we're going to get an x value of -1. So we have two zeros here, positive 2 and a -1. All right, let's take a look at our multiplicities. Remember, that's the exponent that's on your set of parentheses, or your factor. So if we look at the 0 of 2, right, the exponent on this set of parentheses is a 2, which is an even number. And remember, anytime your multiplicity is even, that means that when we're looking at our graph, it's going to touch the x-axis at that 0. If we're looking at the 0 of -1, right, the multiplicity that's on our set of parentheses here, it's really a 1, even though it's not written, right, which is an odd multiplicity. And anytime you have a multiplicity that's odd, your graph should cross at that x value. Let's go ahead and graph our function, and then we can take a look at where our function is going to be less than 0. So let's go ahead and take a look at our graph. And I'm going to give us a little snapshot of our x-axis. And let's take a look at the zeros we had. We had one of the zeros here at -1, and we had this other 0 here at positive 2. I'm going to go ahead and plot those on my x-axis snapshot. And keep in mind that's kind of breaking my graph into 3 intervals. I'm going to go ahead and label this interval A, interval B, and interval C. Right, and let's go ahead and build ourselves a little sign chart with regard to where our graph is either greater than 0 or less than 0. Right, so we're going to be looking at this x-axis piece. And let's take a look at what's happening here in interval A. Right? That's everything up to our x value of -1. So we're actually looking at this portion of our graph. And you'll notice that it's below our x-axis. Right? So all of our y values here are negative. Our graph is below the x-axis. If we look at interval B, right, which is our numbers between -1 and 2, we're looking kind of at this portion of our graph. It's to go all the way up and come all the way back down, right, until we get to this x value of 2, and this whole segment is above our x-axis. Right, so this is where our y values are positive. Right, our graph is above the x-axis piece. And in interval C, right, we're looking at this portion of our graph. This entire portion is also above the x-axis. Right, we have positive y values in that section. Right, so there's a little mini sign chart. Let's take a look at what the question was asking us. They want to know when it is less than 0 and we want to write our answer using interval notation. Well, the only spot where it's going to be less than 0 is where we have an interval that's negative. Right? So we're looking here at interval A, which is everything from negative infinity all the way to negative 1. And we want to go ahead and put a parenthesis on this negative 1 because we do not have an equal to bar with our inequality, right? We don't want to know when it's equal to 0, we just want to know when it's less than 0. So everything from negative infinity up to negative 1, not including negative 1 itself, will be our answer for this question.